Now, we as teachers hear a lot of times students complain about why we are studying all this algebra. It's so boring. What's the point? Well, here's an application problem for you. Imagine that you are throwing a ball upward from a top of a 47-foot high building. Okay, so I had to actually draw this using Desmos because I don't think I can do this good of a job, but this is 47 feet. And then what's happening to that ball? Well, at some point it's going up, right? And it moves like a parabola. And then it reaches this high point, the highest point, and then it starts going down. And at some point it's going to hit the ground right here when the height is 0. Okay. And then we need to figure out a couple of things. First of all, when does the ball reach the maximum height and what is the maximum height? Okay, so to do that, we need to realize that the maximum height is going to happen at the vertex of this parabola, right? Because we already know that that's the largest value. And how do we find the vertex? Well, let's go ahead and do that. We're going to open up Desmos calculator. We're going to enter the values of A. A is negative 16 and B is 56. And that's going to allow us to figure out the H, which is the X, or in this case, T coordinate of the vertex, minus B divided by 2A. Okay, now I think that's it. If you need to round to 2 decimal places, but I don't think you need to do that here. It looks like after 1.75 seconds, the ball is going to reach the maximum height. Now, to find the maximum height, you need to take this number and plug it into the equation. Okay, just like we did before, we are going to, instead of t, we're going to use empty parentheses. Okay, so type that and then insert the value of t that you got. Like, what was that point when the ball reached maximum height? Well, it was 1.75 seconds. We're going to put that in the blank, and it tells us that that's 96 feet. Now, looking at our picture, does it make sense that it's 96? It really does, right? You can definitely see that it's about 90 something, right? 96 makes a lot of sense. Okay. Now, that part is not as hard. The last part is harder. Okay, so what are we supposed to do to figure out when the ball hits the ground? Well, what you need to realize is that what happens to the height of the ball when it hits the ground with respect to the ground? Well, it's going to be 0, right? Because right here, this is where it hits the ground. Right at this point, this is when the height is equal to 0. What that means is that we're going to have to make this equation equal to 0 and solve it for time. Now, the easiest thing we can do is to use quadratic formula, because you definitely don't want to try to factor here. That's not going to be a good idea at all, okay? Let me just erase this part because I don't need this anymore. But let's also define C. C is 47. Now, using the quadratic formula, we're going to compute something called discriminant that is going to be b squared minus 4ac. Now, if you do need it on the test, it's going to be provided. You wouldn't have to memorize the quadratic formula. We can see that the discriminant is positive, which, by the way, means that we're going to have 2 solutions, okay? And let's go ahead and solve them. Okay, so we got 2 of them. In order to figure it out, we're going to click first on the fraction. On the top, we're going to put negative b minus, then square root of capital D, this is your discriminant, divided by 2a. Okay, that's your first solution. Then I'm just going to copy paste this and also change this to a plus. Now remember, we are looking for the time when it hits the ground. There is no way for the time to be negative. The second solution is what we say extraneous. It's not going to be the solution because there's no way for the ball to hit the ground at a negative time. It has to be a positive time, which means that this is your answer. Now, we do want to go ahead and round, and Desmos has a function called round. You just basically type round. And then you can just take this number, or you can actually click on answer. That also works. And then a comma, and then 2. And that'll allow you to solve. And it looks like that's 4.2 seconds. Now, just before we hit submit, does it make sense that it's 4.2 seconds from the picture? Definitely does. It's a little bit more than 4.